Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are, so thanks for joining. Today I want to talk about what might seem to be a simple topic, and that's temperature. We're in the business of heating things, and so temperature is really important to us. And so I want to familiarize you with different locations in the heater where temperature is important and different designations for temperature as you design a heater or specify a heater. So let's talk about that, and I'm going to draw a heater to help in that. Okay, so if this is the burner, and then a heater, of course, has a coil in it, and our heater looks something like that. So it's got a convection section here, and then what we call a radiant section here. All right. So there's process temperature, which is really the temperature of the fluid that you're heating. We call this process temperature, and it comes in here, process in here, and then process comes out here. Okay. And this is the fluid that we're actually heating. Well, we heat it obviously with a burner and flue gas, and so there's air coming in here, and then fuel coming into the burner, and we create a flame, and then hot gases actually make a turn and go up into the convection section. So there's a lot of different temperatures in this system. There's flue gas temperature, which is the gases that you create when you burn the fuel, and then there's process temperature. Let's talk about the flue gas temperature first. So there's one temperature that comes up a lot, and we call this bridge wall. And that's a holdover from many, many years ago of heater designs where the roof of the heater was like a bridge, and someone said, hey, that's the bridge wall temperature. What that really means is what is the temperature of the flue gas after it leaves this radiant section before it enters the convection section. That's the bridge wall. And so that temperature is really most important with respect to emissions guarantees. So when we go and buy a burner from someone, we're going to say, hey, we need an NOx or NOx emissions of this. And the first question they're going to want to know is, hey, what's the bridge wall temperature? Because the higher this temperature is, the higher the NOx levels. That's important. Another important temperature for flue gas is the stack temperature. Okay, stack temperature is a good indication of how much of the heat from combustion are you putting into the process. So if this stack temperature is low, that's a good thing. That means your heater's efficient. If this stack temperature is high, not good. That means you're not absorbing the heat from the flue gas in the way that you think you should absorb it. Typical stack temperatures are in the range of 400 to 600 degrees F. Typical bridge wall temperatures are in the range of 1300 up to 1600 degrees F. So it's really, really hot. That's the important flue gas temperatures. Let's talk about process temperatures. I'm going to erase this first. Okay, so process temperature, let's draw a pipe. I think I'm going to have to get a different marker. Let's draw a pipe, and in this pipe, I've got fluid flowing through it, right? And fluid is coming out. I'm transmitting heat into that pipe. This is what's going on in a heater, right? heat from the flue gas or radiation from the flame is heating the fluid inside of this pipe. So there's one temperature that we call bulk temperature. Okay, that is the average temperature of the fluid coming out of this pipe. I'm going to draw the wall of the pipe a little better here. That's the average temperature. So, but if you think about it, the fluid that's in this pipe, these molecules are going at different velocities. In the center of the pipe, the molecules are moving much faster. On the edge of the pipe, they're moving really, really slow. And right on the surface, they're not really moving much at all. That's called boundary layer. So as you can imagine, there's different temperatures in here. They're not all this bulk temperature. The fluid that's right here, right on the surface, is really hot, and that's called the T-film temperature. It's higher than this temperature. It might be 50 degrees higher. This is important when you select a fluid to make sure that this film temperature doesn't exceed the fluid's allowable film temperature, because if it does, bad things happen. You break the fluid down, you start building up coke on the pipe, bad things happen. So you have to have an analysis that calculates this film temperature really, really well. If you don't, you could have some surprises where you break the fluid down, the heater's just not functioning. The last important temperature here is called T-tube wall. So as you probably guessed, the temperature of this tube wall is actually higher than the film. It's higher than the bulk, higher than the film. It's the highest of all three of these, and it's because it's really, if you want to say, it's closest to the heat, right? This is important from a metallurgy standpoint. If you over-temp this tube wall, the metallurgy can break down and you can have failure of your heater. So those are all the important temperature measurements, temperature calculations that you need to do when you design a heater or spec a heater out. Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.